Hello everyone, if you want to learn line by line code implementation of this live video demo in which a deep learning architecture first detect the face and eyes, and then based on the status of the eyes, if the eyes are closed more than usual time, it can generate an alarm and for informing the driver that you are going to sleep. So it will act as a sleep alert. So if you want to learn all this, please stay tuned till end of this video. Let's get started. My name is Shanullah and I'm a PhD student at Inha University, South Korea. My major is computer vision and deep learning. And in this video, we will be covering drowsiness detection using transfer learning. For this implementation, we will be using Python as a programming language, and for overlaying these text data and all these rectangle, we will be using OpenCV. And for deep learning training the eyes images and open eyes images, we will be using TensorFlow. This is the outline of my today's video. That first we will start with the training of the deep learning architecture for eye status detection, that such as if the eyes are closed or open. And then once we train our deep learning architecture, we will go for the live webcam demo. Okay, before diving into implementation, it's better that we should have some knowledge that what is drowsiness detection. So basically, you can have a face image, and in this phase, for example, this guy is doing yawning, right? Yawning is one of the feature which can detect that a person is going to sleep. But the problem about the yawning is that it varies person to person. Some guys can sleep without doing any yawning at all, right? Similarly, another feature we do have is nodding, but nodding is again like moving your head like this, but nodding is again extreme status of the sleepiness, right? If you are just going to sleep, then you can do the nodding, right? Then again, the nodding also varies person to person. So eyes are the main features, I guess, which can easily detect that if the eyes are closed or your frequency of eyes closing are more than usual time, then you can easily detect the uh, drowsiness, right? But again, you do have a different problem with the eyes as well. That for example, a person is wearing a sunglass, and sunglasses are mostly, they are black, right? So if the eyes are closed, then it will be very difficult to detect the drowsiness. So now we have multiple methodologies in the market. For example, one of them is vision based. So far I have told you anything is vision based. By vision based I mean the camera, right? These all of them are camera images. But we do have another techniques, like rather than vision based technique, we do have physiological sensors. By physiological sensors I mean biosignals, right? For example, what we have, we can have a brain signal, right? And using brain signal we can easily detect like we can also detect the early detection of the drowsiness, that if the driver is drowsy or not. Similarly, we can have EOG signal, like this is vertical channel EOG, this is horizontal channel of EOG. So based on the eye movements of the EOG, we can also detect that a person is going to sleep or not. Similarly, we do have PPG, like based on respiratory. We do have bands which you can wear it, and then based on that we can also detect that either a person is going to be drowsy or not. But again, we do have a lot of problem with this. What if a person forgets to wear it, like before driving? In this case, if we go with a biosignal solution, then before driving you have to wear some uh, uh, gadgets, right? So it's very hard to wear something and you can forget, and it can ultimately we can have some accidents. So it's better, for example, if like in your dashboard, if you do have a camera, it's really easy that based on your camera image you can easily detect drowsiness. In this case, driver don't need to wear anything at all, so it's much easier. So in this tutorial we will be covering only the face detection based on facial features, like only based on the eye features we can detect either the person is rosy or not. And the most easiest one is that if the eyes are closed for more than usual time, then we can detect that, we can generate an alarm that, okay, you are the person or a driver. We can generate an alarm for the driver that you are going to sleep. Okay, so the goal of this tutorial, we are defined now that we have to detect the eyes, and then based on the status of the eye, if the eyes are closed consistently, then we can generate an alarm that you are going to sleep. And if the eyes are open consistently, make sure that we will not count the blink, right? So if it is for short time, it will be considered as a blink. But if it's sustained for more than few seconds, definitely it is not a usual blink, and then we can generate an alarm. So we do have another two methods, like for deploying this for implementation in the deep learning. We do have two methods. One of them is apply customized deep learning model, like we can generate our own deep learning model, right? But this is again, we will have a lot of problems, like we have to make sure all the hyperparameters are working perfectly, and we do have a lot of challenges. Another very easiest solution is transfer learning. So the transfer learning is the most easiest solution. I will come back to the point what is transfer learning, but for the data set, for example, we can use the MRL-I data set. We will again discuss the MRL I data set very easily in next few slides. So first, let's discuss what is transfer learning. For example, you have generated deep learning architecture, you have created it, and you have start learning. So usually what it happens, like for example, it grows up with with few epochs, like with moving. I mean, there is a weight matrix, right? We do have a weight matrix with different weights, and with the starting point, as the more number of epochs, the deep learning architecture try to learn, and our accuracy becomes increased with the passage of time or with increasing number of epochs, right? So once we can achieve like 90% accuracy for any kind of, for example, classification problem, right? So in the classification problem, if we have already solved a deep learning architecture for the classification, for example, cat and dog and other, for example, we do have already trained deep learning architecture. For cat and dog, we do have, for example, then we want to for example, differentiate car and truck. So as the nature of this deep learning architecture is to classify based on the images, you can use the same images, right? Like a same dimension of the image. Then rather than training it again from the scratch, it's better that we perform a transfer learning. In case of the transfer learning, the weight matrix will not start from the scratch. The accuracy will not drop down or will not start from the scratch. Rather, we can start our training accuracy. We will see when we will implement it. We can start, for example, from 50%. I mean, when we will test our accuracy, it will start from usually 50% or 60%, right? So the benefit is that we don't need to train everything from scratch. Rather, we can use transfer learning, but make sure that the nature of the problem should be same, such as it should be classification. For example, if you have already trained classification model for cat and dog, and now you want to differentiate between car and truck, so it's better that you use transfer learning rather than creating your customized model from the scratch. So it's not a good method. The best method is use a transfer learning. So these starting from the scratch would be reinventing the wheel, right? So we should not always reinvent the wheel. Rather, we should go and stepwise we should proceed. So what is transfer learning? We have already discussed, but how we can do it in our case? You might have heard about MobileNet, GoogleNet, AlexNet. All of these are famous classifiers, deep learning classifiers, which are famous on ImageNet dataset, right? In ImageNet dataset, there were thousands and thousands of thousands and thousands of images for at least 1,000 classes. So it's almost 130 GB data, right? So it's already been trained, right? All of them are mobile net, Google net, AlexNet are already been trained on 1,000 classes. In this video we want to, for example, classify two status, either the class either the, for example, let me show you the images, either the eye images are open and eye images are closed. So it's a kind of the binary kind of a binary classifier, right? So the good thing is that all we need to do in the transfer learning, all we need to do is to just use the last fully connected layer, the FC layer. It will contain 1,000 nodes, right? It will contain 1,000 nodes. So all we need is to do is to just use 2 nodes and use the softmax or any other classifier for the binary one. So we need to I mean, if we have a deep learning architecture, last layer, by changing the last layer we can use all the weights, right? So in this video we will be use the mobile net, and we will use for the stepwise, we will code everything and you will see, you will witness soon. So for training the deep learning architecture, we will be using the MRLI dataset, which is open source dataset, and it contains 37 different individuals, right? 33 were men and 4 were women, and they actually this was not intentional for the Drowsiness, rather it is only for the pupil detection and some other this data set was intended to be performed for another application, but for this particular video we will be using it for open and closed eyes detection, right? It's easier to use someone's data set and which was already used for some other application, but in this video we will be using for Drowsiness, right? This will be final methodology, right? For example, after training an image for example closed eyes and open eyes, okay, after training it we can have the okay, we can have, like, for example, face image, we can detect an eyes image. This will be performed in OpenCV, and we can split the eyes in left and right. For example, we have to make sure that both eyes are closed, right? So after doing this, we will have a deep learning model already trained, and the deep learning architecture, if we provide the eye image, it will tell us that, for example, the input is eye image, it will tell this will be eye, right? So it will tell us that either the eyes are closed or open, right? We can have I mean different statuses, right? So if the eyes are closed, we can have some timer, for example, if else statement, that if the timer elapsed for more than 2 seconds or 3 seconds, then we can generate an alarm that the driver is drowsy. Okay, let's dive into the implementation for drowsiness detection. So the tools we will be using in this tutorial are Anaconda. Anaconda is a famous package of multiple libraries and IDEs. So the IDE we'll be using is Jupyter Notebook, and there are other IDEs famous like VS Code and Spider, but in this tutorial we will be following Jupyter Notebook. And for we will be, for deep learning architecture libraries, we will be using TensorFlow, that is by Google, and for some calculation we will be using NumPy. And as I told you before, that for overlaying the text and rectangles we will be using OpenCV. Okay, so thank you so much, and after this we will be dive into the actual implementation. For installing the Anaconda, all you need is to visit the Google and then write Anaconda download. You will find the first link, individual edition Anaconda, and once you click that link, at the downside of this link you will find the executables files, and according to your specification, either you are Windows user, Mac OS and Linux, or your Windows is 32-bit or 64-bit, you can just download it. So after downloading, it's super simple. All you need is to just next. So by clicking the next, it's super simple to install the Anaconda. So I assume that you have already installed the Anaconda, and then after visiting the search bar, you can just click Anaconda Navigator, and then you will reach over here. this window will be appeared in your windows. Over here you can observe that some of them are blue buttons and some of them are green buttons. So green are installed, so once you click this install, it will install the corresponding application. So I have already installed the Jupyter notebook, that is why it's not green, it's just launch button. If I click launch button, my Jupyter notebook will open. But it's better that to have some folder to, rather than opening the launch button here, it's better that you just open using the folder. So at this moment I assume that you have already successfully installed the Anaconda Navigator and you have successfully installed the Jupyter notebook. Once you install the Jupyter notebook, all you need is to create a folder, empty folder, and then you just copy the path. Then again you need to write Anaconda. Once you write the Anaconda, rather than this time clicking the Anaconda Navigator, this time you need to click Anaconda prompt. Okay, so it's better that you write cd and space the path, and let me zoom it for you, and then you need to write Jupyter. So I assume that it's for beginners level, so that is why I'm just using all the steps. So once you write a Jupyter notebook, you will reach over here, but in your case your folder will be empty, right? So all you need is to just click new and then Python. So this the Anaconda will all install the Python and will also install the Jupyter notebook, as I told you before. So let me split this window for myself, and I assume that you have only this window, right? So for this, as I told you, that we do have some installations. So for example, you need to install TensorFlow, OpenCV and all others. You don't need to install import OS. You don't need to install OS because it's already contained in the Python. So I have written all these commands like pip install TensorFlow. Okay, so in order to install the TensorFlow, you need to visit the again Anaconda command prompt, but this time this time you have to right click and run administrator, right? And after running the administrator, you just need to just copy this, and you just once you enter it, pip install TensorFlow GPU, your TensorFlow will be installed. If you don't have GPU, then you can just remove this GPU and it will work, right? So now I assume that you have already installed TensorFlow, you have already installed like all these commands. Just go visit the Anaconda command prompt and right click and run as an administrator, and please install all these dependencies. Once you have already installed all these dependencies, so in order to execute it, you can use this you just click and continue running, or for example you can restart and run all, for example. So it will execute all this. And a second method, which is the easiest method rather than clicking it, is it's shift enter. Let me write for you, shift plus enter. So it's always better that you just follow, it's a shortcut, shift enter. Okay, so shift enter is easy. So once I write shift enter, you see the line number is 2 now. So for example, okay, after doing this, I visit the Google website. Now I assume that your folder is empty, right? So all you need is to write mrli dataset. Okay, so you need to write like this, mrli dataset. So the first link you will be open, right? This is mrli dataset. As I told you before, that this dataset is actually not it was not intended for the Drowsiness detection. Rather it is for some pupil and for pupil localization, right? It's for pupil localization, but in this tutorial we are using it for the Drowsiness detection. So the best thing I found it is that they do have open eyes of 37 different candidates, right? So it's really useful that we can train our data sets. So they have just cropped it for pupil localization. You just click this data set public publicly available. So once you click here, your data set will be start downloading. But as you can see that there is a 2, so I have already downloaded it and moved to my folder. So this is my I have already downloaded, and now I have extracted. And if you extract this folder, you will find like this 37 different candidates. Over here, a little bit, you can say that it's a kind of you have to perform some work, which is super easy. Like you have to, for example, all these closed eyes, all you need is to copy, and create another folder, for example, train data set, and you just copy the closed eyes data set. Okay, or I have just copied all of them into closed eyes, and open eyes, I have copied all of the open eyes into another folder. So rather than using 37 different candidates, what I did is I have created another folder, and I have put all of the closed eyes to one folder and open eyes to another folder. Make sure to have a good name like closed eyes and open eyes, because based on this name of this folder, we can label it as well. So in this tutorial we will be labeling it, right? So I assume that you have downloaded it, and then you have separated like in train dataset like closed and open. So there are a lot of images, like almost 37,000 images each. So in this video it's very hard that we can train all of them, because it will takes, I think, more than hours. So it's very hard to keep in touch. So it's better that rather than doing it, it's easy that we should train it on few images in this video. Okay, so for example, as you can see that this is my current folder, and in my current folder, if I just go to my test dataset and close, so you can just divide randomly. Like I have shifted 37,000 to the training dataset, and for test dataset I have downloaded the all the images, right? Like they are very few, 990. Okay, so in this tutorial I will be using these images for saving my time, but for you guys it's better that you use this train dataset, right? For more images it's better. So more the images, it's better that you can just train it. So I will just write a command C to imread, and in test dataset I'm just for a sample, just to show you that it's working or not, I have read the image, and then I'm just for example, as I have already imported matplotlib, and I have already shown you how to install matplotlib, I assume everything is installed. So if I plot it, it's like this. And if I check the size of this image array dot shape, sorry, it's you don't have any braces, so it's 86 by 86, so it's very short, right? It's 86 by 86, but ImageNet and all other deep learning architectures mostly use 224 and 224, right? So we need to resize this image, but before resizing it, it's better that it's very hard that we have to execute every this command for every image. It's better that we can for example, we can just we can have like a coding like this. For example, this is our training data set, but over here I'm just as I told you before, that for saving time I'm using test data set, and in this case I have created a list, right, of 2 images. It must make sure that it must be the name same to the data set, right? Because I'm using the of the folder, it should be the same name as the folder, because I'm joining the path and I'm reading it. So it's a better way that not only we are using, for example, let me break it over here for the for just showing the first image. So it's better that over here we do have the folder name, and as well as this will be used for our labeling as well, right? So this is our first image. Once I assume that everything is performed, and for example, once we can also check how to resize the image. So I can just have the variable 224 and then cv2 using this command. I can have like this. So CV2.resize 2 to 4, 2 to 4, so it's become 2 to 4 rather than 86 by 86, it become 2 to 4. So now I can, for example, reading all the images and converting them into an array for data and labels, right? uh, for example, for making note, this is a very beauty, this is the beauty of the Jupyter notebook. We can make notes. So reading all images, so for reading all images, I'm just again creating a, for example, this is again a list, and I'm creating a function, creating data sets. And in the classes, what are the classes? We do have only two classes. So if it's super simple, the tutorial we are following right now, it's very you can say it's dynamic, it's very generalized, right? So if you have in your case, if you have any kind of images like cats, dog, and for example multiple images, you do have it, you just copy the in the folder and you follow my all these instructions and code line by line, and you can come up with a very better solution, because we are learning this time transfer learning, right? So it's very generalized, as long as it's a classification problem, and you can have multiple folders as well, and you just copy paste your images downloaded from the Google, and it's super simple, right? So for example, if I created this function, let me call this function. So what's happening inside is that it is, for example, these are the classes, as I told you before. I have two classes which are the folder names as well, and we are just reading every image, every single image in the gray format, because it was already gray. What's the difference between gray and RGB is that RGB has three channels, red, green, blue, while the gray has only one channel, right? We are converting image size. We have not mentioned image size, but we have already mentioned 2 to 4 here, so it's enough that it's the variable is already 2 to 4. And then we can just this is a command of the list to append anything in the list. So this is our data, the new array is our data, which is image, and this is our class number. What is class number? Class number is in the index, for example 0 or 1, right? So it doesn't matter that, for example, you can just write open eyes over here and close eyes over here. It doesn't matter who is 0, who is 1, but all you need is to just know that this is my 0 and this is 1. So ultimately you are performing the labeling on close and open eyes, right? Okay, once we have created it, so let me check the length of my images. So it's 1981 images, right? Like 991 in one, and I think similar to like another. So it's better that you perform some random shuffling to avoid overfitting, right? So it's better that we should not perform the overfitting. And then it's better that before training we can just append again x and y to lists, and then we can append all of them. And okay, let me append all of them. So in this case, it's better that all the training data sets we have stored recently in this list, we are splitting into data and labels, right? The data is our features. So now we have stored all of them. Once we have stored, let me check the size again. So you can see that we have 981 images, okay, and each image has 2 to 4 into 2 to 4 size, and we have converted into the RGB. The reason to convert into RGB is that the ImageNet like ImageNet data set contains all of them are RGB images actually. So RGBs are 3 channels, so that is why I have converted into gray into RGB. So this is reshaping by over here. 3 means 3 channels, right? So I have converted into RGB. Why? Because in order to give it the ImageNet as a in order to give the deep learning architecture which only works on 2 to 4 into 2 to 4 into 3. So in the beginning of the lecture we have already studied what is transfer learning. So in the transfer learning you have to make sure that input size must be the same on which it was previously trained. So after doing this, we can just normalize, right? So it's a very crude method of normalizing it. It's better that you should use sklearn, but as this tutorial is purely intended for the beginners level, so that is why I'm just doing it for 255. And another thing is that although we have converted this training data set into this over here into numpy array, but it's better that we should convert both data and our labels into the numpy array. So over here I'm just converting my labels into numpy array. Okay, so once I have done all this, it's better to save it, right? So save my data. Once it's saving, just write the, now we can create a deep learning model for training. But over here we are not we will not create uh, mm, the deep learning architecture, rather we will be using transfer learning, right? So as this is my node, so it's better that I just change it to markdown. Okay, so it's the beauty of the Jupyter notebook that after a year or any time later you can watch, and for example you can submit the assignment in it as well, because the beauty is that it's already run and your answers are already stored. It's very visually, it's very good, right? That it has been executed successfully. So again, for example, once you have saved it over here, let me generate it. So later, later in peacetime, for example, if you have stored all of them, you don't need to create the folder and everything all the time, right? Now you do have X, the features in the X and the labels in the Y. So later if you want to use this, now in my way, in my RAM it's already stored X and Y, but later, for example, if I close this window and later if I want to use it, I can just use X and Y, right? So I can just load it. So just this is commands to load from the pickle, and pickle is the really easiest one. You don't need to install pickle, right? So it's already installed in the Python usually. So for deep learning, as I told you before, that we need to install import TensorFlow. I already performed this TensorFlow as TF, but let me do it separately again. So now let me import it TensorFlow as TF, and then okay. So the best thing about the best thing about the TensorFlow, that it contains already stored models, right? If you write T as I import TensorFlow as TF, once I write tf.keras, you see I only press the tab, it's completing by itself. Applications dot mobilenet, sorry, if I write the application, if I do the press the tab, you can see a lot of huge number of deep learning architectures already available, right? So in this case all of them are already available, and whatever you like, you can just select. You can just google the specifications of all of them, and you can just if you want a lightweight, the MobileNet is most lightweight one. And if you want, if you don't care about the lightweight one, and if you want some accuracy and others, you can just search it, right? For this case, as MobileNet is accurate and as well as it's very lightweight, so I will go for it, MobileNet. And then again, if you press the tab, sorry, it was a small one, I guess. Again, let me yeah, this one, the small one, right? Then again MobileNet, and then okay. So I have now what it actually, after installing TensorFlow, it has already downloaded it, and if it's not downloaded for the first time, it will download for you. Okay, so this is command is same, and then you can check the model.summary. If I press like this, you see I can check all this model.summary. So it's 4.2 million. Still, it's huge network, but it is considered to be the lightweight. Why? Because it was trained on the 1,000 classes, so that is why it is considered to be lightweight. Otherwise, other candidates, if you go to the applications, for example, if you go to the application and tab dense and all of them, others are very huge, right? You can just run any other, and just you can find the parameters. It will not be 4.2 million, rather it will be more than this, right? So what is transfer learning? Now let's perform the transfer learning. So as I told you, it's already trained. So it's better that we do have already trained network. So let's perform the transfer learning. So in case of the transfer learning, so let me have a base input is a variable, and if I press, for example, if I press model dot and I press the tab, it has a lot of features, right? So I will go for the layers, right? If I go for the layers, then for example, if I want to have 0, why? Because in this case, now I am getting my first layer, right, which is the 0, right, this layer. So my input layer is 2 to 4, 2 to 4 into 3. You can see over here, that was the reason why I reshaped my input into 2 to 4, 2 to 4 into 3, right? So make sure that everything is there. Once I write the layer, and it should be input. In order to, I am telling you, the others actually, if you see input, mask and other things, these are used for the pruning. If you're not familiar with the pruning, so it's for model compression. So over here I have just selected my input. What is my input, right? So this is my input, right? So once I have this variable as an input, then for my output, for example, this is if I go back, it's rather than counting it from 0, 1, 2, 3, rather than having the index, the beauty of the Python is that I can start from -1. So this is -1, this is -2, this is -3, this is -4, right? So let me have a dropout layer, right? So my base output variable, this is my variable name, it can be anyone, right? Base output is equal to model dot layers, and it can be -4, right? Dot output, as I'm using it for the output. So this is my output layer. Once I do have the output layer, so now it is easy that I have you can see that I have ignored these last 3 layers, right? So I'm just, you can say that I've just cut it like this, right? So I'm getting the input and I'm getting the output of the dropout layer, right? So in this case, base output is the output of the dropout layer. Now after having a dropout layer, so I will perform some operations, like for example, I need to flatten the layer, like this dropout layer I will flatten. And then after flattening it, as I told you before, that this is our binary classification. So rather than having dense layer is fully connected layer, right? So rather than having 1,000 layers, it's better that we can have one node, right? So for one node, it's binary classification, either the answer will be 1 or 0, right? So in this case, for example, it can be open or closed, right? So only one node I have. And another thing, you might have noticed that most of the time you use softmax classifier, right, for more than 1,000. You see over here it's a softmax activation function, but over here, as it is a binary classification, so we will be using sigmoid. One another thing I want to let you know, that it's not a good typically it's not a good method that for only binary classification you are using such a huge network, right? It's better that you can use support vector machine and any statistical technique, because it's a super simple problem, right? But in this video we will also covering the transfer learning in an easy way, so that is why. So the reason behind all this is transfer learning. So if you have, for example, 10 classes or 100 classes and 60, for example 600 classes you have, still you can do the same, right? You can for example, if you have 6 classes, it's super simple method, right? You can generate 6 different folders and you can just modify and add this list, right? So it's super simple. So we are learning the transfer learning, right? So I assume that over here you have followed my instructions. So once I've executed it, now the best thing about the Keras is that a new model is equal to Keras.model, and what is my input? My base input, right? This is my input. What is my output? This is my final output. Why? Because I have this was my input, okay, base output. So I cropped this dropout and then I have added these 3 layers, right? Once I execute new model, let me check the summary of the new model again. You see over here, you get till the dropout layer, it's same. For example, till the dropout layer it's same, but 3 more layers have been concatenated, like flattened layer, this one, and then dense layer of only one size, and then the sigmoid is not shown over here, right, as I added as an activation function. So it's reduced like from 4.2 million to it become reduced to 3.2 million. So the last fully connected layer was having a lot of parameters, right? So that is why almost I mean it's huge, right? So that is why now it's only 1025. Okay, so now that we have created our model, it's time to compile everything based on the, for example, okay, so based on for the binary classification, all the settings I need to perform is for the binary classification, right? So this is the new model.compile, and this is binary cross entropy wide. Usually people have a sparse categorical, something like that, cross entropy, so it is for more number of classes, right? But if you have binary classification, it's better that you should have binary cross entropy. And the reason why I just do it sigmoid, so sigmoid is better for the binary classification, but if you have more classes, more number of classes, then go for the sigmoid is the best option. As far as optimizer is concerned, Adam is famous for either it is one binary classification or more. Mostly people use the Adam, right? Okay, so once I have executed, I need to fit it. So I need to now it's time to training, right? So over here we have performed transfer learning, and now I'm going to train. For this video I'm just training only one epoch. Why? Because it takes a lot of time. You can imagine that only for these only 2000 images, it is taking so much time that you can imagine. You see over here accuracy is not started from 0 or 2%, right? Rather it just started from 70% or more, right? As I told you before, this is the beauty of the transfer learning, that it has not initialized all of the layers. One another thing, if your problem is really similar, one another thing, a very important thing I want to mention over here, that you can also perform like model dot layers, for example, yeah, like model dot layers is equal to for example, if you get the model dot layers, you can have that layers dot trainable is equal to false, right? You can just perform layers dot trainable is equal to false. In that case, if you perform layers dot trainable is equal to false, so for example, if you don't want to modify the weights of this layer or any layer, you can just freeze it, and you can just freeze all of them as well, right? So layers dot trainable is equal to false, whatever is the layer. For example, if the layer is first or second, and you can just loop it as well, right? You can layers dot trainable is equal to false. You can also use the layer, for example, for layer in layers, stuff like that, or model dot layers, model dot layers. Okay, you can just perform like this. So whatever you like, for example, selected number of layers, you can just perform, like for example 0 to 1 or all of them as well, right? So you can just perform like this, that layers in this all layers, you can just layer dot go false. So in this case all of the layers will be frozen, right? So you don't need to frozen in our case, as the problem was very much similar, so we don't need to freeze it. So if you want to use it, for example, this was a classification layer, right? A classification problem. If you want to use it for any other problem which is more complicated, and you need half of the layers, right, half of the layers to be fixed, and half of the layer you need to retrain, so you can just do it. You can just perform it by layer dot trainable into false, right? But in this video, as we are our problem is really similar, so we don't need to. So you see the validation accuracy is 54%, which is still not good. But if you go it for 50 or other epochs, even for 10, I can tell you that you just repeat all the steps and it will be very much better, right? So actually, after having this, it's better that you just save the model like this. New model you have already trained, you can just save it. Once you save it, everything will be saved. You don't need to retrain again. So actually, I have already do have stored everything in my computer. I have a Actually, in the peacetime, I have already trained it for many epochs, and it's more than I think 80% accurate. It can reach till 90 if I give more epochs. So in this case, I have only for few epochs I have run, and then I have stored it. So now I'm again modifying my new layer. I'm retrieving from my already stored. Let me show you, like, I have already this is my model that we have just you see the time I have just created this, and I have already pre-stored it a few days back. I have already trained it, so I am just going to load this, right? So when I execute this command, so now my new model will be modified, right? So it's taking time. It's taking time because it is loading all the parameters, right? So once we do have the model, now it's better that we should check the predictions, right? It's better to check the predictions. Okay, so I have already stored one of the image inside my folder. This image I have already copied inside my folder. So let me check. Okay, so what are the things I need to perform? Once I read this image, I need to convert it into the I need to resize. Okay, so my image size is already, as I told you, it's 224 into 224, and now I need to convert it into 3. Why? Because before that it was 86 into 86. Let me check the now shape. So it's one image 224 into 224 by 3, which is what we need, right? So for example, if I let me plot it, so it's open eye, right? So once it's open eye, one thing we forgot, we need to normalize it as well, right? So all these pre-processing steps we already performed before, right? When we were doing it all, you see, we performed the normalizing it. So, we normalize it before. So in order to predict our network, our image, in order to perform the prediction on our model using our image, we need to normalize it first, right? Oh, I double modified it, I guess, because I run it 2 times. So let me do it again. Let me read the image, let me remodify like this, and let me perform it one. Why? Because it's modifying it, right? So for predictions, it's super simple. This is my prediction is my variable name is equal to new model dot if I write the predict, you see it's prediction, and what I need to pass is x input, right? So once I perform, I have already got the predictions. Sorry, shift enter, you see it's 16, it's positive. So actually this image was an open eye. Okay, so let me select this image. Sorry, if I select this image, for example, if I select this image and reperform everything again, shift enter and shift enter, you see this is negative. So I can now predict that if my values are negative, it means my eyes are closed, and if my values are positive, it means my values are my eyes are open. So it's super simple. So all you need is to just run this command on any kind of image, but make sure that you follow these few steps, right? Let's check anything on unknown image, right? For example, we do this was the image with actually it was included in the training, right? Or even if it's not included in the training, so we just perform its lookalike image. So what if, for example, Let's for example, let's Google again. uh, First of all, sad face woman. If I write in Google it, so this is an image. I have already downloaded it from Google. Okay, this is sad woman. So I have already downloaded an image of the sad woman. So let me check, is it working or not? Okay, so this is my image. So in this case, as it is the colored image, so this is the image, right? So its dimension is different, right? But what I do need what I need to do is I need to crop these eyes, right? First I need to crop these eyes. Okay, again, if you want to crop these eyes, you have a CV2, but first you can detect the face and the eyes, right? So in order to detect face and eyes, the famous thing is HAR, or just go to the Google and write HAR cascade face detection XML, I guess. You need to write like this, and once you visit this website, you can just find like this one. This is for this one, HAR cascade frontal faces default. Just right click and save link. So actually I have already stored it like this, so I don't need to. And again, one for eye detection, you need to copy like this, eyeglasses, or it's also simple, save link as. So actually I do have the I one as well, so I don't need to copy. Once I assume that you have already downloaded inside your folder the HAR cascaded eye and HAR cascaded frontal faces, so once you download it, you just need to write the command. So what are we doing? Actually, we are doing it to detect the face using OpenCV. For that we need HAR cascade features, right? And for eye, we do like this. So cv2.cascade, we already have OpenCV. We have done import import cv2. We already executed this command in the first over here, right? We already executed this command. So now I assume that you are here. You have, so this is you need to write for latest OpenCV, right? So I assume that once you install the OpenCV, so the OpenCV will be latest. So for latest OpenCV, you have to write this command. Otherwise, if you Google this is cascade classifier, you will find in the literature most of them without this. But for the latest OpenCV, you have to write these commands. Okay, once I assume that you have uh, okay, so for face detection, actually all the face detections are for in the gray images, so you need to convert BGR to gray. Okay, so once I have converted into gray, then I need to detect different eyes. If it has multiple eyes, it will detect, right? And let me draw all of these eyes. So cv2 dot rectangle is just for drawing the rectangle. I'm drawing the rectangle on my image, like this is my image of sad woman, and xy, and this is actually when I do the multiple scales, it will give me all the coordinates of the eyes, right? So let me execute this command. And now, as I told you that rectangle is overlaid on this image, so if I execute this command again, like a simple control C, and if I, let me show you, this is the same command, right? If I execute this command again, you will find the eyes, right? So eyes are detected, right? So it's based on OpenCV. So now we are going towards this part. So it was the old deep learning architecture is only trained for open or closed eyes, right? But in this case, we need to extract the eyes, right? So actually, now we need to perform the cropping the eyes, right? So now what are we doing? We are doing it's for unknown image, right? We just downloaded, as you can see, we just downloaded this image, unknown image, and we are just cropping, and we are checking either our deep learning architecture we just recently trained on closed and open eyes, will it work or not? So let me cell into markdown like this, right? So crop the eye image, and okay, so these are the images. I'm again using the same command, okay, like I, and then again the gray, this same command, and then I'm just using it for cropping these rectangles, right? So this is ROI is the region of interest for gray, and this command is, you see I'm actually using all the similar commands again just to crop my eyes. Once I have cropped my eyes, now I can just plot this eyes ROI. You see I have successfully cropped the eye. What if I provide this eye image? If me Let me check the ROI. This is ROI, eyes ROI dot shape. So it's different, right? 664, 64, 64 into 3. So we don't need 64, 64, right? We need 2 to 4 into 2, 4, 2 to 4, right? So now like this. So cv2.resize again. So let me check the again the image dot shape. Actually it's resize and normalize. You see it's 1, 2 to 4, 2 to 4 into 3, right? So if I again predict based on my final image, let me predict. You see it's positive. So open eyes, it's positive. For closed eyes, it was negative. You see the predictions were negative. So now we have already defined why, because we have used sigmoid activation function. If you do not use sigmoid activation function, if you use softmax, then you will have a probabilities, and in that case it's easy. It will just for the prediction it can just return you all the labels as well, right? Okay, so now we are successful till this point, that we are just successfully done all these things. So let's dive into our next scenario is a live video demo. In the live video demo, we will be using all these commands, that having live video and then cropping the eyes and then just giving the eyes to our prediction, our model already trained, and then we can perform the live video demo. Let's start our live video demo implementation. So actually so far whatever we have learned, like import cv2 and this path concatenation of the phase cascade, we have already learned. And now this is the new thing, right? So this is for activation of the video webcam, right? So if you for example, if you might have like 0 or 1, right? So it depends upon your registered index of the webcam. If you have multiple webcams, for example 2 or 3 of them, then you will have other figures as well. So all you need is to just pass 1 or 0. You can just try it, but I have written a very dynamic code for you guys, so you just all just follow this command. So if it is 1, then it will open, or if it is not open, then it will start the 0, right? And if we didn't found any kind of the webcam in your computer because of any driver problem or anything else, it will just throw an error like cannot find the open webcam, right? So once we have, for example, in capture, we have captured the video, then while true that we want to run the webcam continuously, right? So we can just retrieve our frame. In this frame, by this frame I mean this image, right? So we can just retrieve this image. It can be of any size, right, based on your webcam, right? So you don't need to bother about what is dimension of your webcam. All you need is to use any kind of webcam available in with you guys. So then after having frame, then we are using iCascade, which we have already used. We've already downloaded this, and then we are converting into gray image, and then we are finding all the possible images if you have multiple persons inside one picture. So for detecting multiple eyes, and then we have a loop in which we are checking all of them. So over here the eyes image is, this is BGR, right? So it's green. Green is 255, so it means the rectangle will be green in color, right? So then if eyes are not detected, for example, it is possibility that the Haar cascade cannot detect the eyes. In that case, eyes it will throw an error that eyes are not detected, right? Okay, if it is detected, then it will just crop the eye images, as we have already executed this command. So actually over here we are just using this extra commands. Rather, if you have visited so far all the videos with attention, so you can review it again. So we have learned all of these commands, right? Now again we are resizing everything, and then we are expanding one dimension, as I told you before. If not, then let me tell you again that we need 4 dimensions. So actually 2 to 4 into 2 to 4 into 3 we need it, but you can imagine over here that this is 1, right? So it needs 4 dimensions. Either it should be 1 or number of the images, right? So that is why we are expanding the mm, image dimension, right? Then we are normalizing the image, and then we are performing the prediction, that new model dot predict, right? So in your case, if you close it, so you can execute this command, right? If you have saved your model like this, if you have saved your model already, you can just copy and paste the same name, and please execute it for more than I guess I would recommend more than 10 epochs at least, right? So then you have new model. If you have already stored, just run this command, you will get the model. So I assume that you have already run have the model in your RAM. So now you have already executed that command. So predictions dot new model. So far, if you have followed each step, so you will not find any kind of trouble, right? Any kind of problem. So as we have seen that if it's open eyes, it must be positive. Let me check. If open eyes, our predictions were positive, right? And if our eyes were closed, our predictions were in negative in number, right? Let me zoom for you guys. It's too much zoomed. Okay, so now for example, okay, so if it's positive, then open eyes. If it's negative, then close eyes. So this is our status, and then we can just draw the faces as well. Okay, this is for race faces, face rectangle as well, and then the face rectangle is also a BGR, so it's green in color. And then the status will be written, whatever you write over here it will be written, and it is frame which have been captured. And this is the for example, this is the offset of the image, that where do you want to paste this font, right? This is the size of the font, and this time the font will be BGR. The font will be in red in color. Okay, and this is the title of the Drowsiness detection. Let me execute. If I press shift enter, I will have like this. Okay, so you see if my eyes are open, right? It's also detecting my mouth as well actually. So if your eyes are open, it will say it's open. Okay, if my eyes are closed, let me close my eyes. So I hope it have shown you the closed eye, right? As long as my eyes are open, it shows open. It has some because it tries to detect. So if you have a very clear background, it is more accurate. My background is not clear, so that is why it's not like this. So if I close my eyes, it shows my close. But now this was not our main goal, right? So our main goal was to have some alarm as well, right? So once you have learned this, let me close it. For closing, you need to press Control C, I guess. Okay, so I assume that so far everything is good. Then in order to generate, uh, for example, if the eyes are closed for more than some time, right? For example, more than a blink. So because right now, if you might have noticed that it sometimes it also detect that your eyes are closed. It is the reason because sometimes it also detect the frame in which I was blinking. Actually, I was not closing my eyes for more than a few seconds. So that is why it is detecting closed eyes, right? So all you need is to just copy and paste all the code, right? And one important thing you need, like import win sound, it's also in Python. You don't need to install anything at all, and you need to write that frequency 2500, and you can just set your frequency in hertz, milliseconds, and whatever you want. Okay, and rest of the code is same. You can just check. And one important thing I have included over here is that previously this was not a part, right? So previously it was only open eyes, right? Like this over here. So in this case I have added again, like having some put some text, and then what I'm doing over here is that I am like, this is the my dimension where I want to start. This is my offset, and I am writing some rectangle, because if you have noticed previously, it was open eyes and close eyes over here, so it was not good, it was not better in viewing, right? So it's better to have background black. For example, in this case it will be black, like 000, all of them is black. If you want to make it white, you can say 255, 255, and 255, right? So in the put text, I'm BGR, so it's green again. So if it is active, then it will be green. So if eyes are open, I will draw a new box, black box, and I will put text active in a green color. If my eyes are closed, for example, I have some counter, like counter 0. Okay, I've initiated counter 0, and if my counter is more than 5, I'm doing it counter plus plus. If my eyes are closed constantly for each frame, for example, then I have to write red in red color. For example, I will write a black box, and in red color 0 BGR, right? R is 255. So in that sleep alert. Okay, so let me execute shift enter again. So in this case, you see over here there is a black option as well. So if I blink, so actually it's also detecting my blink, right? So if I blink, I close, and it's, so it's close eyes, and it's red in number. So let me close my eyes. So you heard the sound. So actually it, when I close my eyes for more than few seconds, it start beeping. Although you see, when I close my eyes, it don't beep. Why? Because it only shows the closed eyes. But my, for example, my duration of the eyes closure is more than usual. For example, you can set, if in the if statement you can set, you can just have more sensitivity based on sensitivity, right? So for example, let me close my eyes for more time. You see, it is having it's alarming continuously, right? So its active status, it is black, it looks good because of the background. This is also open eyes and close eye, but it's better. So you can set your sensitivity, because my background is very colorful, so that is why over here it has some uh, outliers as well. But I hope in your case there will be no outliers, and it will perform the best. Thank you so much. See you in next video.